Hello again, students, and welcome back to my YouTube channel. So we're moving on in our real functions chapter 13. We're moving on to our second part where we start exploring systems of linear equations. We learned how to graph equations, of course, in our last unit, especially linear ones, but we're always graphing one at a time. In this particular case, I'm going to introduce a system of equations that we can actually portray as two different graphs, or two different lines on the same graph. I mean to say, y equals 4x minus 2 and y equals negative x plus 2 here are given to you. These are both in image notation. In real function notation, of course, you may see it written like this, where I say 4 times the identity relation plus negative 2, and then below each notation I'm putting that little subscript of r, meaning it's over the set of real numbers. That's going to be our domain. So relatively simple, of course, to graph, because I just put down an intercept on that L2 axis of negative 2, and I see the slope is 4 here, either way I'm reading it. It's the slope of 4. Recall again, slope is rise over run, so it's as a fraction. So I just need to write 4 as a fraction, which is easy. I can just write 4 over 1. That means I go up 4 over 1. And I have a relatively easy graph to draw here, something like that. I didn't draw it too terribly straight, but that's okay. I'll just use the scissors here and slide it over. Perfect. And let's do our other one here. Y equals negative x plus 2. Again, in real function notation, I'd have negative 1 over the set of real numbers times the identity relation over the set of reals. And then I've got plus 2. So I know I'm crossing at 2, and now my slope is negative 1, so that means I'm going down 1 over 1. And I can just draw a line through points that would portray that. Now, of course, when I say we're going to solve systems, what we're interested in, most interested in anyway, is going to be that common point of intersection. And as I look at that, it almost looks like it's 1, 1, but that can't be, because if I put 1, 1 in either of these spots, while it works for the green one seems to work, negative 1 plus 2 is 1, but it doesn't work for my purple one up here. I've got 4 times 1 minus 2 equals 1. That's not right. Rather, the solution for this particular system winds up being 4/5, 6/5, which of course is quite a bit different than 1, 1. It's close, but it's definitely different. This is the solution that would work for both of these. Now, such a system, by the way, is referred to as being a consistent, meaning it has a solution, an independent system, meaning the lines are different from each other. So, this is a consistent, independent system. And I bring this up because when dealing with systems of linear, that is first-degree equations like these, one of 3 things happens. You either have one solution, like I just showed. You could also have infinitely many solutions, and such a system would be consistent and dependent. And you also might have no solution. A system with no solution is going to be inconsistent. A system with no solution, any idea what that's going to look like? Do you think? If you said a couple of parallel lines, then you're right. That's what no solution is going to look like. So what do you think infinitely many solutions is going to look like if it's a dependent consistent system? Think about that. All right. I'll get back to that some other time. In the meantime, exercise 127 portrays some situation that they ask you to graph as a system of linear equations. So let's take a look at this one. I'll jump over to my Safari here, and you can see on exercise 127 you've got, you can make a line for a boat, line for the barge. Since they talked about the barge first, I'll go ahead and graph that one first. It says it leaves location A with location coordinate 60 at time 0 hours. Wait a minute here. What is this? It's a time zero. Time 0 is going to be that's going to be our horizontal axis. So it's so if 0 is down here, actually this point needs to move up all the way up to 60. Yeah, so that's going to be a point in the graph because it tells us as much. And it goes, so it goes downstream to location B at a constant speed of 6 kilometers per hour. So if it's going down on the graph, That's relatively easy to portray. If I'm just going down 6 over 1, like so, let's see, down 6 would be perhaps like this. So in 1 hour, it should be at 54. So let's move that there. Whoops. I think that'll work. Sure. And we can see pretty clearly that it's going to take 10 hours for it to go 60 kilometers, which makes sense because if it's going 60 kilometers per, whoops, I accidentally moved it there. Let's move it on down. Here we go. Yeah. Let's try the boat now. Let's see, because I read the directions on the boat. It says the boat leaves location B at 5 hours and goes upstream to location A. Okay, so if location A was 60 kilometers, from where, that's where it started, and location B is all the way down here at 0, so that means, but it leaves at 5 hours, so that means it's going to start here, and after 1 hour, it's gone 5 kilometers upstream. So 5, 0, 6, 10 should be a point, right? Because if it's going upstream at 5 kilometers per hour, yeah, it should be, should look a little, well, something kind of like that. Oh, wait, not 5. Oh, I misread. If I did this, it's going 10 kilometers an hour. That's no good. It's not really going 10 kilometers an hour. It says it's going 4 kilometers an hour. Whoa, that's going to be much, much less. So we should really have this point down here. There we go. That makes sense. Indeed, going downstream, you should be able to go faster than going upstream, unless you're on a power boat. Anyway, but yeah, this graph, this looks much, much better. Now, the next exercise, of course, is going to ask you to consider the barge and boat. Now you're actually going to write the functions. Please note the domain, if the domain of f, now remember f is going to be the function that corresponds to the barge, and that's our blue one here. So as we're doing the barge, that's the domain. Remember, it's going to start at 0. So the domain of G, if G is going to be the boat, where does that start? Makes sense. Here's another thing too I should have mentioned. Back up here on my graphs, remember the right now these lines that I have, let me get rid of that. The lines that I have, these aren't lines, these are rays. Boats don't go forever, do they? So in fact, what I really need to do here is I need to make endpoints on these. So I need to tap on that and say endpoint included. Oops, there we go. And make an endpoint included on this one, although now it's actually keeps making me go down here for this. I need to let's try this again. Here we go. Endpoint included. I think that worked. I hope. And all right, and so I got to, whoopsie. One thing about these things, they're kind of temperamental. You have to remember to switch over your graphs as you're doing these. You got to switch where your lines are. So for this one here, it's going to end at 60. Should take 15 hours, so that means it's going to be at 20. There we go. Let's make this say endpoint included. There we go. Let's do this endpoint, whoopsie, endpoint included, but now I'm going to have to drag it again. Get it to 60. This makes sense because after 15 hours at 4 kilometers per hour, 15 times 4 is 60. But again, it'd be a mistake to put this point here that I've got, the last one I've gotten right there in the center of the screen. It'd be a mistake to put that at 1560 because that would only be true if it started at 0. You were told it leaves location B at 5 hours, not 0 hours. So, again, as you go to do exercise 128, make sure you're putting the domain in correctly. So 0 is where the barge starts, and what time does it end, right? I'm going to leave that up to you to figure out. And then, of course, E, it's going to start at 5. See if you can use this information, of course, to figure out the correct equations that describe the functions here on exercise 128. Okay, so I would like you to go ahead and work up through exercise 129 on pages 91 through 97. And IXL skills for this unit that are going to help you with your learning are going to be those Algebra 2 skills, E1 through E5. Yes, go to Algebra 2, that's in the high school section. Try to do E1 through E5 to sharpen your skills at solving systems of equations. Thank you for watching my video today. Be sure to smash that subscribe button as well as the like button for this video, and I will see you again soon. Be good for your parents. Bye-bye.